All right, today we're going to be working on simplifying square roots. Another word for square roots here is radical, so you'll see me kind of go back and forth between those two words. Here's some vocab. The first one, it says a factor or a divisor. I usually use the word factor. It's a number that goes into another number. All right, so for example, a factor of 4 is 2 and 2 and 1 and 4. Okay, so factors are what you can multiply by another number to get to that larger number. We'll talk about rationalizing the denominator a little bit later on. And the big thing here is a perfect square. It's an integer that is the square of another number. What that means is if I take a number like 2, if I do 2 times 2, that gives me 4. All right, so a perfect square would be the square root of 4 because when I take the square root of it gives me a perfect number. These are the list of all of the perfect squares here. How I write them, at the very top of all my papers, I write those out, but I write them actually as like the square root. So it's like the square root of 4, square root of 9, square root of 16, square root of 25, square root of 36, square root 49, square root of 64, square root of 81, square root of 100. I usually only write out those first couple there. The list kind of goes on and on because it's all just like 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, etc. So we can make the list go on infinitely, but again, I just go up to 10 squared for my purposes. So what we're going to do here is we're actually going to simplify all these. So what we do is we look for the biggest perfect square that goes into each number. So here's our first one, 48. So what I do is I look at my list here, and I know that I start at the very top and work my way down. So I know 100 doesn't go in there, 81 doesn't go into 48, 64 doesn't, 49 doesn't. If I do 36, that doesn't go in perfectly. 25 doesn't go in perfectly, but 16 does. If I were to type in 48 divided by 16 into my calculator, I would get 3. So what I do is I break this up into the square root of 16, because that's the perfect square that goes into it perfectly, and the square root of 3. Now I look at this and identify that I know what the square root of 16 is, because that's a perfect square. The square root of 16 is 4. It's on our list there. The square root of 3 is not on our list, so I just keep it as the square root of 3. All right, so that would be my final answer, 4 radical 3, or 4 square root 3. Let's repeat the process for 32. Now again, you start at the top of your list. You know 100, 81, 64, 48, and 36 don't go in there because they're too big. 25 doesn't go in there perfectly. All right, 16. 16 does. If I take 32 and divide it by 16, I get 2. So I do the square root of 16, the square root of 2. I know that the square root of 16 is actually 4. So this is 4 radical 2. All right, so that's how you simplify them. We can also do operations like addition and subtraction. So for problem number 3 here, all right, it says 6 radical 5 minus 2 radical 5 plus 8 radical 5. So in order to do addition or subtraction, they have to have the same radicals. So let's look at all their radicals. We've got radical 5, radical 5, and radical 5. So since they all have the exact same radical, we can actually add or subtract them together. And how you do that is it's like adding x's or y's or variables. You look at the numbers out in front. So I have 6, negative 2, positive 8. So if I do 6 minus 2 plus 8, I get 12 radical 5. Okay, so you notice my radical is still the same as my other ones from before. So you just look at that outside number there. Okay, number 4 says 5 radical 6 plus 3 radical 2. So let's look at those radicals there. 6 and 2. Are they the same? No. So can we add these two together? Nope. So my answer would just be what it is. 5 radical 6 plus 3 radical 2. You can't combine them because they're not the same radical. And we can't simplify either of those. All right, number 5, we have 2 radical 45 plus 8, or radical 8 plus 4 radical 20. Now, none of those are similar radicals, right? So we can't add them together. But we need to reduce those because I think all of those can be broken down. So let's look at 45 first. So we're going to look at our perfect squares up here. All right, I'm going to start at 36. I don't think 36 can go in there perfectly. 25 can't go in. 16 can't go in. Ooh, 45, 9 is a factor of 45, so I can do, keep that 2 out there. I know 9 goes into it 5 times. A little bit smaller here. All right, and I know the square root of 9 is one of our perfect squares. The square root of 9 is 3, so I've got 2 times 3 radical 5. 2 times 3 is actually 6 radical 5. So I've reduced that down. We're going to do the same thing with 8. Now I know, and my perfect square is up here. 9 can't go into 8, but 4 can go into 8. All right, 4 goes into 8 2 times, so I can say radical 4 and radical 2. Radical 4 is our perfect square. The square root of 4 is 2. So this would be 2 radical 2. Okay, 4 radical 20. 20 can be broken down. 4 is a factor of 20. So I can say we've got radical 4, radical 5. The square root of 4 is 2. So I'd have 4 times 2 radical 5, which would actually be 8 radical 5. So now we have this problem down here. 6 radical 5 plus 2 radical 2 plus 8 radical 5. In order to do addition or subtraction here, they have to be the same radical. So I see radical 5 and radical 5. So I can combine these two things together. So I can say 6 plus 8. Well, 6 plus 8 is 14 radical 5. Unfortunately, there's another radical 2, so you just say plus 2 radical 2. Okay, so try to always simplify them down first before you add or subtract them. If you have larger numbers, they're going to be able to be reduced usually. We can also do multiplication. Now, when we do multiplication, we multiply like terms. And what I mean by like terms, you're going to multiply the coefficients out in front of the radical together and any numbers under the radical, under that square root together. So here's my example. I've got 3 and 2. Those are both numbers on the outside there. So if I do 3 times 2, I would get 6. I can also do radical 3 and radical 5. Well, radical 3 times radical 5 would be radical 15. Now I'd look and see, can I reduce 15 also? Let's look at our list up here. We know 16 can't go into 15. 9 doesn't go into 15. It's not a factor. And 4 isn't a factor of 15. So I think that would be our final answer here of 6 radical 15. Here's another example here. So we have our outside numbers, ones that aren't in radicals. So I've got a 3 and a 2. So 3 times 2 would give me 6. I only have one radical here. That's just radical 5. So that would stay as radical 5. Okay, I can't multiply 2 and radical 5 together because they're not like terms there. They're not the same thing. One's a coefficient and one's a radical. All right, for this problem here, we've got 2 radical 3 times radical 6. All right, so I'm looking for just my coefficients. I've got 2. That's the only coefficient I see, so that's going to stay as a 2. I'm going to look for radicals now. I've got a radical 3 and a radical 6. Well, radical 3 times radical 6 is radical 18. We're going to look if we can simplify 18, so let's look at our list of perfect squares if any factors of 18 are on there. Well, I think 9 is a factor of 18. I'm going to break that apart. So I've got 2 radical 9. 9 goes into 18 2 times. All right, I see radical 9. Radical 9 is a perfect square. The square root of 9 is 3. So I've got 2 times 3, radical 2. 2 times 3 is 6. So I've got 6 radical 2 as my answer. What we have here is we have a fraction. So you notice it's got 5 over radical 3. Now, as a teacher, as a math teacher, the radical in the bottom, we don't like. It's like nails on a chalkboard. We don't like that. So what we're going to do is we're going to rationalize the denominator. What that means is your goal is you want the denominator, that bottom part of that fraction, not to have any radicals. You just want a plain number. Okay? So what I'm going to do here is in order to rationalize it, you're going to multiply it by the radical itself. So I'm going to multiply the bottom by radical 3. If I multiply the bottom of the fraction, to be fair, I have to multiply the top of the fraction as well. So the top, I've got 5 times radical 3. Now, those aren't like terms. One's a coefficient and one's a radical. So the top would remain 5 radical 3. The bottom, we have radical 3 times radical 3. Well, 3 times 3 is 9. And we're going to look. Well, the whole point of us doing this was to get rid of the radical in the bottom. If you look at this, radical 9, that's one of our perfect squares. The square root of 9 is actually 3. So I can say 5 radical 3 divided by 3. And you'll notice now in our denominator, there's no more radicals. The last thing you're going to look at here is the numbers 5 and 3. All right, can I divide 5 by 3 perfectly? No. So my final answer would just be 5 radical 3 divided by 3. Okay. Number 10, there's a couple different things we can do here, but if you notice, we've got a radical in the bottom. We don't like radicals in the bottom, so to get rid of that, we're going to rationalize the denominator by multiplying by that radical. On top, I've got 6 radical 10 times radical 2. I see 2 radicals, 10 and 2. That would give me 20. So I've got 6 radical 20 over radical 2 times radical 2 is radical 4. Let's think. We know radical 4, that's a perfect square. That is actually just 2. So I've got 6 radical 20 divided by 2. Let's look at those numbers out in front. 6 and 2. Can I reduce 6 and 2? Yeah, 6 divided by 2 is 3. So I've got 3 radical 20. And now let's look at that 20. Can we take 20 and simplify that? Well, yeah. Look at 20. 4 goes into there. So I can say 3 square root of 4. 4 goes in there 5 times. 4 is our perfect square here. The square root of 4 is just 2. So my final answer would be 6 radical 5. All right, number 11 here. Same thing, we've got a radical on the bottom, radical 3. To get rid of that, we're going to rationalize the number by multiplying by the same thing. So I've got radical 3. If we do it on the bottom, we have to do it on top. All right, up here, we've got 12 radical 2 times radical 3. So I see 2 radicals here. All right, so I keep the 12. Radical 2 times radical 3 is radical 6. On the bottom, I've got radical 3 times radical 3. Radical 3 times radical 3 is radical 9. I know that radical 3, or radical 9, or the square root of 9 is just 3. So I've got 12 radical 6 divided by 3. Here, look at the two numbers out front. 12 and 3. Can I simplify 12 and 3? Yeah, 12 divided by 3 is 4. So I've got 4 radical 6. Perfect. Okay, up next we've got 5 radical 6 squared. When you see this squared, that just means you're multiplying it by itself. So what I do is I rewrite it twice. So 5 radical 6 times itself, 5 radical 6. Okay, we're going to multiply like terms here. So I see coefficients 5 and 5. Well, 5 times 5 is 25. And then I've got 6 times 6, or radical 6 times radical 6, which gives me, radical 36. I see that the square root of 36, or radical 36, is one of my perfect squares. The square root of 36 is just 6. So I've got 25 times 6, which is actually just 150. All right, last one's here. We've got this. So you notice now under the radical, we have a fraction. So it says the square root, or radical 25 over 9. So what you do is you can actually split the fraction up. So I can actually say the square root of 25 divided by the square root of 9. So let's see if we can simplify these. The square root of 25, that's a perfect square. The square root of 25 is just 5. The square root of 9, also a perfect square, is just 3. So my answer would just be 5/3. Same thing here. We're going to break it apart. So I've got the square root of 27 over the square root of 9. Now, 27 isn't a perfect square, but let's see if we can break it apart. I think that the square root of 9 goes into that. So I've got the square root of 9. Now goes into 3 times. I know that the square root of 9 is a perfect square. That is just 3. Up here, I've got the square root of 9. That is just 3 as well. So I've got 3 square root of 3 over 3. Look at those outside numbers there, those coefficients. 3 divided by 3 is just 1. So I've got 1 square root of 3 as my final answer. You could also just write this as the square root of 3 or radical 3. I would take either answer. Last one here. Break it apart. So I've got the square root of 9 over the square root of 27. All right, the square root of 9, that is a perfect square. That would just be 3. I've got the square root of 27. Now the square root of 27, all right, we got to break that apart. I think that will break up into 9 and 3. So I've got the square root of 9 and the square root of 3. I know that the square root of 9 is just 3. So I've got 3 over 3 radical 3. Look at those outside numbers. Can I do 3 divided by 3? I can. It's just 1. Now this is an okay answer, but we have to remember, do we like radicals in the bottom? No. All right, so we need to get rid of that radical by rationalizing the denominator. So I'm going to multiply both sides by radical 3. So on top, I've got 1 radical 3 over radical 9. I know the square root of 9 is 3, so I've got 1 radical 3 over 3. And that would be my final solution.